Yeah, lesson 61. We get to play games today.
Is it actually like fun games or just like?
No, it's not really. It's not really games, but it's more looking at how does a function relate to the first derivative and the second derivative, which we've already done a little bit of, and you already have a lead into how to do some of these because you already know a lot of these relationships. It's just going more into it and we're doing different things. So we are today. So example 1. Given that f of x is ax cubed plus b, that the graph of f passes through 2, 25, and that f prime of 3 is equal to 81, find a and b. Oh, hey, someone else just joined us. It's an Abby.
Yeah.
Oh, that's all right. We were just really concerned that you of all people would be missing. So you have a partner in crime today, though. Ross has joined you, so. Now we just need. And for the purpose of Ross and Abby, we are down to just 3 in class. Maddie is also absent today, but I don't know anything about her absence, so.
She said she didn't feel good.
Okay.
So.
And not feeling good could be just not feeling good, or that could be leading towards other things at this point. It is so hard to know. Okay, so given f of x, we have a point, we have the derivative at 3, find a and b. Do you guys have thoughts on where you want to start?
We can use the point and like plug it in.
Okay, so we can use the point, and this is, we have 2 different things we can look at here. We can use the point and the fact that this is 225, right? So this is an x and a y value. Or you can also say f of 2 is equal to 25, because when you put in 2 for x, you're going to get 25 out. So if we go ahead and plug that in, then if we put in 2, notice 2 is going in for x, right? So I'm going to say a times 2 cubed plus b, and that is going to equal 25. Clean that up a little bit. 2 to the third is 8. 8a plus b is equal to 25. That alone, is that alone going to help me find a and b? No, but it gives me an equation to work with, right? We know that 8a plus b is equal to 25. What else can we look at? Yeah. We're given some information about the derivative. So if we find the derivative, we can then plug in that information. Kind of like what we did here. So let's talk about finding our derivative first. So f prime of x. Remember, as we find this derivative, we are working with respect to x. A and b are just numbers. They're constants. So what's the derivative of a x to the third? 3a x squared. Multiply the 3 out front, subtract 1 from the exponent. Plus, what's the derivative of b? Okay, it's just 0. It's a constant, so the derivative of a constant is gone. And so, if we use our derivative information, f prime of 3 is equal to 81. So that 3 goes in for x. So 3a times 3 squared, and that's going to equal 81. 3 squared is 9 times another 3 is 27. So 27a equals 81. Well, that works out nicely, doesn't it? And if we divide, a is 3. If a is 3, yeah, we can take that a and plug into our other equation that we had, right? So 8 times 3 plus b is 25. 8 times 3 is 24. 24 plus b is 25, and so b is 1. Okay. So again, knowing what we know about f of x, f prime of x, looking at those connections, that was obviously the easy, more obvious variety. Questions on example 1? Okay. I think I have next, I'm pretty sure I have example 2 on the next screen. So example 2. The function f is a real quadratic function whose graph passes through 2, 9 and 0, 1. And the slope of its graph is 6 at x equals 2. Find the equation of f. So notice what is f that we're trying to find? It is a quadratic. Okay, you've got to pay attention to the fact that f is a quadratic. If we gather some information here, we know it passes through the point 2, 9. So that's an ordered pair, that's an xy ordered pair, or if I do like I did earlier, f evaluated at 2 equals 9. That's good notation to be comfortable with in calculus. They are very likely to give that type of notation as opposed to saying the ordered pair notation. So the graph passes through 2, 9, and also it passes through 0, 1. So I can also say f of 0 equals 1. What about that next piece of the sentence? The slope of its graph is 6 at x equals 2. Derivative, yes? So that's saying the derivative of f when x equals 2 is going to be equal to 6. So f prime of 2 equals 6. And again, this is me gathering information, guys. That's exactly what I'm doing here. Okay, so our job is to find the equation of f. What kind of equation were we told f is? It's a quadratic function, specifically real, but it's a quadratic function. What equation do we know for a quadratic function? Go more than just x squared, though. What's a standard form of a quadratic function? My hint would be, my hint was going to be if you think about quadratic formula, what form where do we get those ABCs from for quadratic formula? So ax squared plus bx plus c. So they told us it's a quadratic. We know that. Kind of like if they said it's linear, we'd think more like mx plus b, or maybe you'd say ax plus b, those type things. They told us it's quadratic, so we're using this form. There's a couple different things we can do here. Thoughts?
Would C just be 1?
Would C just be 1? I agree. And the easiest way to show that would be if you find f of 0, so putting 0 in for x. So a times 0 squared plus b times 0 plus c, and f of 0 equals 1, correct? So yeah, if you plug in 0, we're going to find that the equation it creates is just c equals 1. What else would you like to attempt?
Plug in 2.
Can we plug in 2? If nothing else, it's going to give us an equation, right? And so if we plug in 2, f of 2 is going to be a times 2 squared plus b times 2 plus c, and that has to equal, what does f of 2 equal? 9. Now you could be smart here if you want. What do we already know about c? C is 1. Could we use that information? You could use that information and replace c there, couldn't you? So if I clean that equation up, I'm going to have it in terms of a and b. And so let's see. 4a plus 2b plus 1. Whoops, I am thinking a step ahead. Equals 9. Knowing what I know, can we go ahead and move that 1 over? And again, that's some of me knowing where we're going with this next, but just we normally tend to put constants together, right? So I'm going to write this equation as 4a plus 2b equals 8. Okay. I'm going to square that. Not that that's an answer, but we just need to kind of hold on to that information, right? So we know c is 1. We already had that. We have this equation to help find a and b. And if you think about what we've used f of 2 equals 9. We've used f of 0 equals 1. What have we not used? Our derivative, yes? So go back. What is our main function here? Our main function is that f of x equals ax squared plus bx plus c. Let's work with that. F prime of x. Derivative of ax squared is going to be 2ax. Move that 2, multiply 2 out front, subtract 1. Plus the derivative of bx is just b. Plus the derivative of c is 0. What do we know about f prime of x? Plug in 2 and set equal to 6. So f prime of 2 is going to be 2a times 2 plus b. And that equation is going to equal 6. If I clean that up, I'm going to have 4a plus b equals 6.
We're going to do like substitution.
Substitution, elimination, whatever makes you happy there. Because what do we have? We have 2 equations that are in terms of a and b. And so, we could also, So I have 4a plus b equals 6. And we have 4a plus 2b equals 8. Ethan says substitution. My brain goes to elimination here. Can you find your a's and b's somehow? I'm not against, it's one of those things, I'm not against elimination, or excuse me, substitution, but my brain went to elimination. Because if I just subtract these, 4a minus 4a cancels. b minus 2b is negative b. Should have set this up the other way. 6 minus 8 is negative 2. And so then I know that b is positive 2. If you did this differently, that's, And then plug the b back in somewhere. So 4a plus 2 equals 6 is what I'm doing. 4a equals 4. A is 1. What were we originally supposed to do? Always good to go back and reread is my point here. We found A, B, and C, but what was the point of this question? And the question was to find the equation of F. So don't stop. I mean, you've gone to all this work. Don't miss the point for finding the equation. Remember, my equation was f of x equals ax squared plus bx plus c. We have since found A, B, and C. So f of x equals 1x squared plus 2x plus 1. We all find our A and B somehow or another there. Whether you followed my route or went a different route. Okay. I'm ready for example 3 when you guys are. If, can't read that from that angle. What is that? F double prime of x is 10. F prime of 0 is 2. F of 0 is 3. What is the equation of F?
Right?
What?
0.03, right?
We will have a 0.03. Which technically, if you think about the 0.03, that's also going to be your y-intercept, if you want to think that way. Notice we have second derivative information, first derivative information, and original information, right? If we think about this second derivative here, f prime of x equals 10. And if you think about the equation, that is the same as saying the equation y equals 10, right? So in this case, the point I'm trying to get you guys to realize, your second derivative right here is a constant function, right? Because our second derivative, the equation for the second derivative is f prime of x equals 10. So in other words, y equals 10. So second derivative is a constant. What does that mean, a constant equation? What does that mean the first derivative is going to be? When we're taking derivatives, we decrease the power, right? What do you do if you're going the other way? You're going to increase the power. So if this is just a constant, what's the next step up from a constant? Not squared yet.
Oh.
What'd you say? Linear. So the idea is that the first derivative is going to be a linear equation. Okay, so this was because they gave me the second derivative as a constant. So then if you go up a power, and up a power from a constant is x to the first. So my first derivative is linear. What's my original function going to be then? Quadratic. Because again, we're increasing powers, right? So what I'm trying to get you to think here is, okay, if we're given a constant, linear, quadratic. So when we write the equation of f, we know that it's going to be a quadratic. So that's kind of your goal in the end. Now I'm trying to look and see how I've written this out in the past. If we know the second derivative, how do I find the first derivative? What'd you say?
I guess integrals.
Yeah, integrals. Sorry, I'm back to I have an AirPod in one ear, and so I'm realizing I don't hear as well when I have an AirPod in one ear. So, yeah, if we know the second derivative and we're trying to find the first derivative, we're going to integrate. And so what we can look at here is that f prime of x, so the first derivative is going to be equal to the integral of the second derivative. Okay, are you following my thinking here? My first derivative, which is, we're working towards finding that right now, is going to be equal to the integral of the second derivative. So I wrote the integral of f double prime x dx. But don't we know what f double prime is? It is an equal sign. There, is that a little bit better equal sign? If you're asking, Robbie, I just combined Ross and Abby there. My goodness. Ross and Abby may really be asking. Goodness. Okay. So we know f double prime of x is 10. So what we're really integrating is 10 dx.
Oh, yeah.
What is the integral of 10? 10x this is an indefinite integral.
Plus C.
I don't have any boundaries, so I need to say plus c. Because we could end up with multiple c's, I'm saying plus c1, just for lack of confusion, because we could end up with multiple c's in this problem. Now, so what we know right now, we just found the first derivative to be equal to 10x plus c. Do we know some information that could help us here? Help us to find c, that is.
So we can evaluate what the f0 equals to. Plug in 0 has to equal to.
Okay, yeah. I listened to Shively and Ross at the same time, and I agree. You guys both, I know you guys don't know each other talking, so it's fine. So yeah, we are using the fact that f prime of x equals 10x plus c. We are provided up here f prime of 0 equals 2. Okay, officially what I'm going to tell you is to plug the information in. So f prime of x equals 10x plus c1. Well, if I plug that in, f prime of 0 is 10 times 0 plus c1 equals 2. Which I agree then works out to be c1 is 2. Okay. Just realize officially we're plugging the values in. So if they don't give you 0, you need to be plugging that value in. So based on the fact that c1 is 2, what is my equation of the derivative? It was 10x plus c1. It's now 10x plus 2. Now, I'm not done yet though, am I? Does this match up with what we are expecting? The first derivative is linear. Did I end up with first derivative linear? I most certainly did. So now we have to go another step. We know the first derivative. How do we get to the original function? We're going to integrate again, aren't we? Essentially, pretty much the same process. So, let's see. This time, f of x is going to be the integral of f prime of x dx. I don't like writing on that side. I'm blocking more of a view anyway. So, f of x is the integral of the derivative. So we are integrating What is our derivative? 10x plus 2 times dx. What is the integral of 10x plus 2? Integral of 10x, add 1 to the power, makes it x squared. Divide by that power, 5x squared, plus the integral of 2 is going to be 2x plus c, and now you see why I'm using a different c. I'm saying plus c2. Okay? And here goes chemistry. It's carbon. Okay. Now, you guys know where we're going here, right? We just found that f of x is 5x squared plus 2x plus c2. Notice we're finding it to be quadratic. That's what we expected, right?
Oh my goodness.
So, were we given some information? F of 0 is 3. So, use that information. F of 0 is 3. So I'm going to go 5 times 0 squared plus 2 times 0 plus C2, and that equals 3. So, of course, that tells me that C2 is 3. Carbon is 3. Does that mean anything to you guys? And final answer, f of x equals 5x squared plus 2x plus 3. Okay. It is a lot of just putting the pieces together and trying to follow them. Questions on anything here?
Now I have other questions.
No, but he has other questions related to the AP practice questions. So, okay, before I forget, and I know I've already said this, but making sure everyone's clear. Okay, this was lesson 61. Tomorrow I'm scheduled to be gone, assuming nothing changes. I'm being lazy. Last year I missed lesson 62 also. So I'm using last year's pre-recorded lesson of 62. So it's not me teaching the class, it's me teaching a pre-recorded lesson. So the days will be off, and I think you hear me say that lesson 62 homework is due Monday when I return because it was a Friday last year, things like that. Hopefully you can ask questions. It's work. Monday or tomorrow's lesson is work, which goes more with physics. And last year I was teaching to a group of 5 boys that were all in physics at the same time. So hopefully if there's anything I need to elaborate on Thursday, let me know. Okay, but it is about work, which is a physics thing. So you get to do the calculus version of it now. So tomorrow, I think Mr. Garner might be my sub. That's last I knew. You have lesson 62 available to view, and in fact, when I post 61 today, I'll post 62. You'll have the homework from 61 to do, the homework from 62 to do. You guys are calc. Judge how you want to use your time, right? Okay, I'm going to stop this recording.